Hare Krishna everyone. So in today I will going to start with a new topic, that is our stability analysis of our physics. Okay. Let me start with your introduction section. Yes. So it's a very important topic in your physics, as well as your in your mathematics also. When you study your stability analysis, you consider mainly three terms, that is your maxima, minima, and your equilibrium point, and somehow you also consider that the point of inflection into account when you study your stability analysis. Okay, we will talk in details about these things. Okay, so let me start with your definition, that is what we call the equilibrium point, or where we can find the our stationary point or equilibrium point. Okay, so the definition of that is point at which the point at which gradient gradient of the function becomes zero, of the function becomes zero. Okay, so what do it mean by, if I have a function f of x, then if I will have to find the stable equilibrium point or stable point, then that it will be equal to your slope, that is your del f by del x is equal to 0 is your stable point. Okay, do you get it? Yes. So in order to define your minima, maxima and point of inflection, I will have to draw in diagram for you. Let me draw that. Let me consider a path like this. Let me change the color of the pen. Like this. If I have considered this point is called, let me give it a point P, and this one is a point Q. This point, if I will consider this point, it will call your, this is your slope is your 0, and this point is called your minima. Okay, minima. And this point is called your maxima. Here also your slope is 0. This point is called your maxima. Okay, where slope is 0. And if I consider this point, if I consider this point as name is, this point is called your point of inflection. Okay, point of inflection means this point is neither your maxima nor your minima. Okay, so how do we find the minima mathematically? How do we find minima and your maxima? Okay, let me talk about it. In order to find minima, you have to first find the equilibrium point, that is your del f by del x or gradient. You have to find the equilibrium point, or you can say it as your slope. Okay, you can say it as your slope. Then at this point you have to calculate del square f divided by del x square. Del square f del x square. Okay, you have to take the second order derivative of this function so that you can find the minima. If the at that point, at which point your function is greater than 0, the value of del square f divided by del x square is greater than 0, then that point is known as your minima. Okay, which is also known as your stable equilibrium point. Okay, this minima is also known as your stable equilibrium point. If I talk about the minima, let me suppose here is the minima point, this is P, then this one is your stable equilibrium point. Why I am saying it as your stable equilibrium point? You see, if this is your main position, then if the particle, if here is a ball and it moves around this, a particle will come to the point P in its main position. Okay, regain its original position. position for minima, but in case of maxima it doesn't regain its original position. When I talk about the maxima, you have to first calculate the del f by del x, and if del square f by del x square is negative, here it is positive and here is it is negative. So this point is called as your maxima. Okay, do you get it? I will do some problems for you. Okay, those have already come in your exam. Let me start with a example first. If I will take a example, let us take a function. Your f of x is equal to x cube minus 3x plus 3. Okay, you have to find the maxima, minima and the stable equilibrium point. Let me find the gradient first. Del f by del x is equal to your 3x square minus 3. Okay, this is your del f by del x, and let it equal to 0. So it will become, if you solve the equation, you will get 3x square is equal to 3 and x square is equal to 1 and x is equal to plus minus 1. Okay, this is your stable equilibrium point. You can say it as your equilibrium point. Let us calculate the second order derivative. Okay, if I will have to calculate del square f upon del x square, it will become your del f by del x is 3x square minus 3, so it will become 6x. Okay, so if I will have to calculate del square f by del x square at your x is equal to plus 1, then it will become 6 into 1, 6, which is greater than equal to 0, so it is your minima. Okay, if I will have to calculate del square f divided by del x square at your x is equal to, okay, if I will have to calculate del square f by del x square at your x is equal to minus 1, so it will become 6x, 6 into minus 1, so it will become minus 6, which is negative, so it is the maxima point. Okay, do you get it? Yes. This one is a question. Let me do another problem for you. This one comes in your CSR net, in which year I don't remember particularly. So let me write the question for you. Free energy F of a system depends on a thermodynamic variable phi, as the function is given as f is equal to your minus a phi square plus b phi to the power 6, where your ab is greater than equal to 0. Okay, so the question asked that find the value of phi if the system is in thermal equilibrium. Okay, let me find out for you. The question is given that the free energy function f is equal to your this much, and where the av are the constants and its value is positive. Okay, you have to find out the value of phi in thermal equilibrium. So the question gives you a hint that it is in thermal equilibrium, so you know that for equilibrium you have del f by del x is equal to your 0, isn't it? So del f by del x is equal to 0. That implies if I will have to take the derivatives of f with respect to x, so it will become your minus 2a phi plus 6b phi power 5, isn't it, is equal to 0. So it will become, for the solving you can get 2a phi is equal to 6b phi to the power 5. So it will become 6b phi to the power 5 is equal to phi and phi getting cancelled, so it will become your phi to the power 4. Okay, phi to the power 4 is equal to your 2a. So phi will become your 2a upon 6b power 1 upon 4. So for the solving you can get phi as your a upon 3b power 1 by 4, isn't it? Yes. So you get the value of phi. The question is asked to find out your value of phi. So you have got the answer. Okay, let me proceed further with another important question for you. This one is also comes in your exam, that is the potential the potential of a diatomic diatomic molecule as a function of as a function of distance r between the atoms is given by basically it was given that potential is in the form of your r, is your function of r. And what is r? R is the distance between the atoms. Okay, the potential is given by Vr is equal to your minus a upon r to the power 6 plus b r to the power 12. Okay, this one is given your potential, and you have to find out the value of potential, value of potential at equilibrium separation. Okay, again you mark one hint in the question, that is equilibrium. If equilibrium is given, you remember that you have to find out the gradient, that is your del v upon del r. Okay, or your dv upon dr. Let us derivative that one. Solution dvr upon dr, as equilibrium is given, that implies dvr upon dr is equal to your 0. That implies dvr, if you take the derivatives, you will get 6a upon your r to the power 7 and minus 12b upon your r to the power 13 will be equal to 0, isn't it? So for the solving, you can get 6a upon r to the power 7 is equal to your 12b upon r to the power 13. Okay, so it will become your r to the power 6 is 12b upon 6a. For the solving, you can get 2b upon a, isn't it? Yes. So what is the value of r? R is equal to your 2b upon a power 1 by 6. Make it a box. You got the value of r. Let us find out the potential. Our aim is to find out the potential. Okay, so VR will become how much? VR is a by r to the power 6 plus b by r to the power 12. So put the value of r here. So you can get a minus a upon your 2b by a plus your b upon 2b by a square, isn't it? So it will become minus a square upon 2b plus your a square b upon 4v square. Okay, so it will become minus a square 2b plus a square upon 4b. So it will become minus a square upon 4b. Okay, do you get it? This one is the value of your potential at equilibrium, minus a square upon 4b. Okay, you got the answer? Yeah, very good. So questions also come from the application point of view. If you have to find out the angular frequency of small oscillation, that is your omega. And also the questions comes, you have to find out the frequency and time period also. Let us do some kind of problems of that. Okay, so if let I am taking a spring, a rigid support here, and with a spring I have a mass that is m, and let me displace it to its mean position. This is your mean position. I am taking the small oscillation. Okay, this is the application of your stable equilibrium or your stability analysis. Okay, if I have the potential Vx is equal to half kx square. Okay, so del V upon del x will become kx. So if I will find out the del square V upon del x square, so it will become k. So I know that k is equal to your how much? M omega square. Okay, So omega will become your k upon m root over. I have k as del square v upon del x square upon m, isn't it? Yes. You can say that del square v upon del x square, where x is your stable point, okay? I can write omega in this form, okay? Do you get it? So we will do example of this, okay? We have the question like this. We have potential Vx as minus ax square plus bx to the power 4, okay? So first of all, calculate del v upon del x. So it will become minus 2ax plus 4bx cube, isn't it? Yes. Give it equal to your 0. So it will become minus 2ax plus 4bx cube is equal to 0. So from here, you can calculate x as your minus 2a plus 4v x square is equal to 0. That implies x is equal to 0 or your x square is equal to 2a upon 4b, okay? And you can write it x as your root over of a upon 2b, isn't it? Yes. So there are 2 points. You got 2 points. You got two values of x as x is equal to 0 or x as a upon 2b root over, okay? Let me find out the del square v upon del x square for both the point. As x is equal to 0, that will become your minus 2a, okay? Okay, let me do the derivative first. I have directly used the values, okay? So you have del v upon del x as this. If you derivative, you can get its value as your minus 2a plus 12bx square, okay? So del square v upon del x square at your x is equal to 0, it will become, at your x is equal to 0 will become how much? At your x is equal to 0 will be equal to minus 2a. This is negative, so it is your maxima. It is your maxima and we don't need it. We don't need it because we need the stable point. We don't need it. For stable point, you have to calculate the minima. So we have another point for x, that is x is equal to your a upon 2b root over. So this one, if you put the values minus 2a plus your 12v x square is your a upon 2b, isn't it? So minus 2a plus b, we got cancelled out, 2 6, so it will become 6a, so 4a. So k is your 4a, okay? We have k, we have omega as your k by m root over, so it will become 4a upon m, okay? This one is your expression for angular frequency or omega. So questions comes from these categories only. You have to just remember how we calculate and what are the steps, okay, for minima and maxima. For remember, for stable equilibrium point, you have to calculate the minima, okay? So for this video, I have all this for you. Thank you for watching. Do like, share and subscribe to my channel. Thank you.